Yeah, to give you a background, Jocivan been working with me as a undergrad like independent study. So he has been applying the GIS technique for the the road safety issues. So he will share what he has done and also what he learned during the independent study. So let's welcome Jocivan. Jocivan, you can start.
Okay, I'm just starting the presentation. Hey, good morning, everyone. My name, no, let me restart. Hey, good morning, everyone. So I'm here today to give you all a quick walkthrough on the makings of a GIS application, while also highlighting the use of programming in civil engineering. So before going into the makings of an application or programming, I want to give a quick introduction of myself. My name is Jocivan Cabrera. I am a fourth-year civil engineering major here at UCF. Currently in my second semester of undergraduate research, where my research project revolves around this GIS application that I'm working on. A little bit more about my GIS project. The issue I'm trying to address currently is highway construction related damage claims, where contractors are setting this almost unobtainable level of evidence required for your claims to go through. So that's a big issue because obviously their construction is causing the damages, but they're not taking any responsibility for it. My approach to that issue is supporting those claims with geospatial information, specifically through the use of Python programming and ArcGIS APIs. I'll expand a little bit more about each of these later on in the presentation. So programming and civil engineering, currently there's this disconnect between programming and civil engineering, mostly because we as civil engineering majors don't really consider programming as something in our area of work, where we tend to focus more so on just like structures, waters, or roads. But the truth is programming has a lot of benefit to civil engineering if we give it some time. So it can help us automate mundane or repetitive tasks, and it can also help us simplify complex equations or problems, and also allows us to do an in-depth analysis of models, such as maybe a physical or structural model. As some of you may know, if you go down the structural route, you'll eventually reach a point where the structural model is too complex to do by hand calcs. So in that case, a program will be really, really useful. And last but not least, there's always the potential to have a money-making idea. This money-making idea isn't the easiest to come up with, but it's very, very possible, especially considering some of the resources we have here at UCF. Okay, so on to the GIS application. For those of you that don't know, GIS stands for Geographic Information Systems. It's similar to GPS, but it has a few little tweaks. GIS can basically be thought of as, I'm not sure if you can see the full image here. Let me move this over here. Okay, so GIS can basically be thought of as maps with data on it, as seen in this little picture here, where each of those layers contains data. So they're basically just compiling it on top of a map. And this is useful to identify trends in areas or forecast any needs for communities. So what are the steps to creating a GIS application? Well, the whole process is iterative, so you're going to be going through it multiple times, not just once. But you're going to start off with thinking of an idea. So for now, it doesn't have to be some groundbreaking idea. If you're just starting off in programming, it can be some simple idea, maybe just pull up a map on your computer. Next, you're going to consider how can that idea come to reality. You have to consider it from multiple aspects, considering how will it happen and what is needed for it to happen. And once you have all of that in mind, you can go into step 3 and finally put all those components into action. And then leading into step 4, where you're going to trial your program and see what works and what doesn't work. And based off what doesn't work, you can readjust your program and fine tune it. And like I said, you're going to be going through this process over and over. You might think that you'll think of ideas just once, but in reality, you might think of multiple ideas throughout the process that you can incorporate into your program. And that's going to call for you to go through the process all over again. For the sake of this presentation, I'm going to be focusing more so on how a GIS application can be made. So if you want to make a GIS application, you need like 4 basic components, those being a programming language, GIS capabilities, some form of input, and some form of output. So for programming languages, if you're going to make a program, then that's going to call for a programming language. Some examples are C, C++. Many consider this programming language to be a good starting point. It shows a lot of the syntax for multiple programs. There's also Java. This one's a little bit more complex, and it's more so used for web applications. And there's also Python, which is a very simple one to understand, relatively simple to understand, and a great starting point. When choosing a programming language, it's important to consider the strengths and the limits of each programming language. So such as what can the program process, or maybe you're more familiar with one programming language than the other, or possibly one programming language has more documentation. Documentation basically being a reference manual for the programming language. And the limits is basically just considering what can't the programming language do for you. So for now, I'm going to be focusing more so on Python. So if you're choosing Python as your programming language, I recommend you get an integrated development environment, also known as an IDE. That's basically a Python processor similar to how Word is, where it'll give you like the option to file, like save and edit your program. Because if you just use Python straight as is, you're going to be typing into a black box and you can't save your code from there, and you're going to have to script your code. And it's just a little more work. And if you're new to programming, then it's probably better that you use an IDE. And if you do use an IDE, then I recommend you get Anaconda. Anaconda is a Python distribution, and it basically comes with all of these IDEs. As you can see, it comes with Jupyter Notebook, and I'll also be focusing on Jupyter Notebook for this presentation. So GIS capabilities. So Python as is doesn't come with any pre-programmed GIS tools or functions that you can use straight from the get-go. So with that in mind, would that mean we have to make everything from scratch? And the truth is, not really. Thanks to APIs. APIs are application programming interface. So those three words might sound kind of overwhelming together, but in reality, it's not that hard of a thing to use. Typically, you can think of them as program plugins, where they have like predefined and pre-made functions and tools that you can use. So somebody else already made that part of the program, and you can just pick and choose whichever ones you need for your specific application. And this really helps out with cutting down on programming time and really lets you focus in on the specifics of your program. So here are some sample API providers. Some of them are Google Maps, ArcGIS, and Bentley. For this presentation, we'll be focusing more so on ArcGIS, mostly because ArcGIS is a more well-known GIS software. Also, the Python API is free, and it has a bunch of documentation and tutorials. So if you're new to it, it'll really help you get familiar with the API. So another thing you have to consider is output. You might have noticed that I skipped input, but that's because I think output is pretty important, because you can think of it as the goal or the reason for your application. Basically what you want your application to do. And once you have an output in mind, you can now consider the input for your program, which is basically what is needed for your program to do what it's meant to do. Some quick examples would be a click or entering coordinates into your program. As I said before, GIS is basically maps with data, so possibly some form of input could be a data set, and your program just takes that into account and processes it or does something with it. So here are some quick resources if you are interested in making your own application. You can go to this website, the first one here, to get Anaconda. You're gonna have to download the one specific to your computer, because there's two options: a 62-bit and a 64-bit and a 32-bit, and that all depends on your computer. And if you're not too sure which one's best for you, then you can just look into your computer settings or do a quick Google search to find out which one's best for you. And to install the ArcGIS API, you can go to this website. You don't need to download anything. You can install it straight from Anaconda. And if you're not sure how to do that, then this link will show you exactly how to do it step by step. And also, we're not just limited to making applications on desktop. If you're also interested about making a phone application or mobile application, you can also do that with ArcGIS APIs or SDKs. SDKs being software development kits. Basically, it provides you with all you're going to need to make a GIS app. So you can make one. You can make an app on iOS or Android. But let it be known, if you're trying to make an app on iOS, you're going to have to be running iOS on your computer. And if you have a PC, then you're probably not going to be doing that. But it's still an option. You can still run iOS if you want to and do that. But I'll be focusing more so on the Android Studio. And if you want to make an Android app, you can go to this website and download Android Studio. And to get the ArcGIS app SDK, you can go to this website at the bottom down here to get that. Okay, so now I've explained like the components and the process of making a GIS application. So now I'm just going to do a quick live demo to kind of show you how it all comes together. Yep, a message here. Yeah, basically GIS. It's basically like fancy Google Maps. So let me put this over here. Okay, so this is, let me hide this. Okay, so this is basically the Jupyter IDE, the Integrated Development Environment. So this is what you're going to be seeing. This is way better than the other option, which is just Python straight as is. So let's start a new project. I'm going to make a simple little app, and you're going to choose Python 3. I'm going to walk you through it. It shouldn't be too complex, and I'll try to explain each process as I go. If you have any questions, feel free to let me know. Let it be known, though, that I'm not like an extreme professional on this, so I'll try to answer them to the best of my knowledge. And I can't see the chat. Okay, there you go. So if you have a question, feel free to just shoot it in the chat or unmute yourself. So as I mentioned before, if you're trying to make a GIS application, you're going to need an API. But to use an API, you're going to have to import their libraries, which is the first thing we're going to do. So you're going to import from ArcGIS.gis. So what I did right there is from the ArcGIS library, I'm specifically importing the GIS tools. And then I'm going to import specific, oh, whoops, I did that wrong. That should be from ArcGIS, and then you're going to import the specific tools you want, which is going to be GIS for us. So what this tool does is that it allows us to use the basic functions of ArcGIS, such as making a map and accessing their servers. And you're still going to want to import a few other things. So I'm going to import the geocoding library. Import geocode. Okay, so basically from here now I'm importing specifically the geocoding library, and from that I'm importing the geocode and reverse geocode functions. So what these functions do is allows me to convert coordinates to points and points to coordinates. And also, if this seems like kind of like how am I knowing this, I've read the documentation, so I'm a little bit familiar with what I need to import. But if you read the documentation, you also know what you need to import to create your program. And there's one more thing we need to import, which is the geometry library. And from there, we're going to be importing the point function. So this one is just going to allow us to make a point. And basically, that's the first step. And to use the GIS library, you're going to have to sign into the GIS server by doing this. You don't need to have an Esri account to use it. It's going to ask, well, typically, if you want the full to use the full extent of it, you're going to have an account. But for now, you don't need an account. So you can just leave it blank as is. And next up, I'm going to try it. Whoops. I'm going to try and make a point, a mystery point equals. So basically what I did here, I just made a variable and I'm setting it equal to a point. And so right now it's just going to be a little bit more of syntax stuff than we're going to be doing. Put an open bracket here. So as you all may know, to enter coordinates, you need both an x coordinate and a y coordinate, which is what we're going to be doing right now. And the input required for this point function is X and Y coordinates, which I don't have them memorized, but I have them right here. So I just made the X coordinate. I just defined it right now. And let me see if I can do the Y coordinate now. Okay, and then one other thing that the point function needs to work is a spatial reference. So what a spatial reference is basically, it's kind of self-explanatory. It just lets the API or the GIS server know in which context to put it in, since there's multiple coordinate systems. Reference. What I put there is a WKID. That's a well-known ID. That's basically the identification number for each coordinate system. And I'm gonna put it as 4326. And boom, that's how you make a point. I'll show you in a minute how that works out. So we just made a point. 4326, I believe, goes with, I forgot which coordinate system that one goes with. And then I'll make a mystery map equals, so I'm making a variable, and then I'm just going to put gis.map, and I'm going to put location equals So some of the input required for the map function is it's going to need a location where it's going to center on, and it's also going to need a zoom level. I'm going to set that equal to 15. So that's how you make a map. And like after all this is done, I'll run it, and then you can see what all of this does. And with a few lines of code, what you can do. Mystery map. And what I'm doing right now is I'm having it, so in putting mystery map.draw, I'm having it draw the point onto our mystery map. Oh, whoops. How much did I put mystery? Let me clear that out. And what I'm doing now is just calling for that mystery map, and now it'll pull up the map, and it'll also draw our little figure on there. I'm gonna try and run it. If it takes too long, did I do something wrong? GIS map. Maybe GIS. That's weird. All right, so in case that happened, I also came prepared. As I said, I'm not a pro, so that was probably a little mistake I made somewhere around there. So this is what the program would have outputted. This is exactly the same as I made over there, except that here I've signed into a little like false account that ArcGIS has for users. So what would have been the output is this map. And as you can see here, it's interactive and you can zoom in and zoom out. But as you can see, it drew the point here. And I'm not sure if any of you are aware what that point is, but that point is actually the classroom for this lecture. It doesn't show classroom building 2 here. That's one of the little issues with ArcGIS API, but that is actually the coordinate for your classroom. So the process wasn't that hard. I know you saw me like make a little mistake in the last one. I have to take a closer look at what I did there. But as I said, this is the same process, and with a few lines of code, you're able to make a little map. From this, you can't really make an application, but this is the starting of an application. So I also want to quickly show the Android application. So I have Android Studio. One of the issues, let me hide this. So one of the things for Android Studio is you're going to have an Android device. As many of you probably don't have Android devices, that might be an issue. But thanks to Android Studio, you can make a virtual device. And I'm quickly going to show you how to make that. What this application does is pretty similar to what I just demonstrated, except that it's not going to show a point or at all. It's just going to pull up a map on a phone. So I'm just quickly going to show you how to make a Android virtual device. Let me start all over again. So you're going to go to here, this option, and you're going to go to the Android Virtual Device Manager. And as you can see, I already have one made, so I'll use that one in case something goes wrong again. But you're going to want to create a virtual device. And then here it comes like a bunch of options. So it'll give you like Android phones or tablets, but you're going to want to choose a simple one. And not all of them work, so it's kind of a trial and error to see which ones work. But I know for sure that the Galaxy Nexus does work, so you're just going to choose that one. Going to go next. And you're going to choose this R API level. I'm not too sure what the R and Q difference is, but the R1 always works, so choose the R1. And I'm going to call it class sample. And you're just going to call finish, and it's going to create the virtual device. And what this virtual device is, it's basically just going to pull up a phone on your computer, and it's going to function just like a phone, except you can't make any phone calls on it. But it'll run your application on that virtual phone, and then you can see how your application works. All right, so there it's done. All right, so I'm gonna try and run it. This might take a minute because my computer is kind of slow, not gonna lie. You might hear it like the fans go wild in a minute, but it should run, and hopefully it doesn't take too long. But while that's loading, does anyone have any questions about the process? I know I kind of went a little fast there. So it's an emulator that can run the code? Yeah, basically, yeah. So the virtual device is an emulator. Yeah, it is an emulator. And it'll just run the application as is.
Jocivan, you have a comment in the chat box.
I addressed it just now. It was the, so it's an emulator that can run the code.
Oh, this is actually, yep.
All right, so it's still running, as you can see. It takes a minute. I can quickly talk about Android Studio. So Android Studio doesn't use Python, doesn't use C++. What it does use is a programming language called Gradle. Gradle is based on another language. I forgot which one it's based on. And it also uses Java. So it's two programming languages in one thing. So that might sound a little complex. I would probably recommend doing a GIS application once you're a little bit more familiar with programming in general. Another thing with Gradle and making an app in Android Studio is that there's going to be repositories throughout. Repositories are basically like little folders that are going to have information that are vital for your code to run. So that's another thing that you're going to have to consider. And that's basically a quick run through of Gradle. Here you can just see the Gradle app folder, and this is the SDK version that I'm using. More SDK versions. Build types, I'm not too familiar with Gradle or Java. I made this a long time ago, so my apologies for not being too in depth with it. But it takes some consideration to make it.
So while we are waiting, Jocivan, he actually been working, this is his second semester he's working with me, but when he started, he had a zero background of programming, right? Mm-hmm. So can you explain your your experiences?
Yeah, that's a good point. So when I started this, I had close to no idea what I was doing with programming. I saw some lines of code, and I was just like, it looked like a foreign language to me. But I believe some of the issue that I had was that I kind of thought that programming was something too complex for me, and I never really put the effort or time into it. Once I actually did try to learn it, it actually turns out it's not that difficult. It just takes time and practice. The bigger issue is just learning the formatting and the syntax of things. But as I investigated resources to use, I learned that it wasn't too difficult to use, and I became familiar with the formatting. And as you can see, like just 2 semesters in, I have like a solid understanding of what I'm doing with programming. And I forgot to put in the resources slide, if you are interested in programming, there's this website called Pi4E, I believe. It's PY4E. You might want to do a quick Google search to make sure that I'm right. But it's this entire like introductory course to Python, and it's very beginner friendly. Really recommend it. Would you say every civil engineering should know coding? That like really depends on the field. If coding is always like a very beneficial thing to do. I remember one of my professors said that eventually computers will be running things. So are you going to be the one that's going to be told by the computer what to do? Or are you going to be the person telling the computer to do? And obviously it's better to be the one telling the computer to do. So having a background knowledge is always valuable in any field, to be honest. It's much more important in specific fields of civil engineering, such as maybe transportation. You're going to be doing a lot of data analysis there. Or if you're going into water design, hydrologic design, that also calls for a lot of programming and like data analysis. So what program would you recommend to start learning first? Oh, so that's a good question. So I would heavily recommend Python. It's fairly simple to understand and there's like a bunch of resources to use. I previously took a course in Intro to C. Wasn't my favorite course, truth be told. It was a little kind of hard, got kind of hard later on. But having like a very basic understanding of C and having somewhat of an understanding of HTML, I would say Python is the easier one of those three that I've used. And
Seems like Jocivan, seems like your build is done.
oh yeah, right, my bad. I got distracted. Okay, so here you have the emulator. As you can see, it's a little phone on my computer, and you can drag around and move around. So this is basically what your application would look like on an Android device if you were to like fully make it. And as I said, it doesn't show the full circle. So this application is basically just pulling up a map on your phone. And as you can see, it's interactive. So you can interact with it like if it was an actual phone, and you can kind of zoom in and zoom out, although I can only zoom in because I'm using a mouse. And now it's like kind of froze there. But that's the basics of making an emulator and knowing and seeing how it runs. And this tutorial to make a basic map app on a phone is also available on ArcGIS's website. They're loaded.
And Jocivan, we need to wrap up in 2 or 3 minutes, okay?
Okay, that's good. I think I covered all the points I wanted to touch on. Do you have any field work or GIS or mostly programming? I would say mostly programming. I've had some experience with GIS through past internships, but nothing too in detail. I wouldn't even really call it GIS, but it's mostly been programming. What are other best types of programs one can use? That's a good question. I'm not too sure if I'm qualified to answer that question, considering I don't have much experience with that. Probably I tried Java too, I guess, because Java is also pretty popular. But like I said, it has its specific syntax things that you have to consider. Now let me close out this. Any other questions? Oh, my computer might just freeze.
Yeah, you need to upgrade your computer.
Yeah, I need to upgrade my computer.
Okay. All right. I think we need to wrap up. So thank you very much, Jocivan.
And thank you all for your time and for your attention.